In this lesson, we're going to be having a look at the qualities and the properties of light. We're going to be going through visible light, ultraviolet, as well as the infrared spectrum. Let's say we have this light source. Here, it may be depicted as a sun, or it could perhaps be a light bulb. And if we were to move and we were to increase the distance from this light source, we would find that the light intensity decreases. But what is that relationship? So we can see here, if we are 1 meter away from our light source, we could say that the area that all of those photons need to cover is 1 square meter. If we were to move to 2 meters away, then suddenly that area that needs to be covered by the same number of photons becomes 2 by 2, which is 4 square meters. So therefore, the light intensity is a quarter of what it was when we were only 1 meter away. To the same effect, if we now move to 3 meters away, that square area that needs to be covered by exactly the same number of photons becomes 3 by 3, which is 9 square meters, and therefore our light intensity drops to 1/9 of what it had been when we were only 1 meter away. So what we can say is that the relationship between light intensity and the distance from the light source is that the light intensity is inversely proportional to the square of the distance from the light source. Let's have a look at the spectrum of natural light. What we have is we have visible light as we know it in terms of the rainbow of colors of light that we can see with our naked eye. Then on the one side, on the red fringe, we have infrared light, and then on the other fringe we have ultraviolet light. With much shorter wavelengths. So if we start looking at this graph that we have over here, where we look at number of photons versus wavelength of the different spectra of light, what we find is that light has got wave particle duality. So as much as the different spectra have a wavelength in terms of the wave properties of the light, what it is that the photons are actually the particles that are transmitted, especially from the sun, because what we have is from our sun in our solar system, we don't only have photons that it emits, but a lot of other particles as well, charged particles are emitted by our sun. And we're going to get to that in a later lesson in our series. In terms of solar radiation. So over here, we can see on this graph to the left-hand side, at the short wavelength end, we have the ultraviolet light, and that is split into UVA, UVB, and UVC. So ultra high energy light is UVC. In that UVC spectrum, this is incredibly dangerous for any kind of life forms, and we're going to see in another picture that we are protected when we are on our planet Earth. We are protected from UVC by a number of factors. And then what we have is we have UVB and we have UVA, and then our visible spectrum, and then we have the infrared spectrum. So the infrared spectrum is actually relatively low energy, and that is why it's associated with heat. Heat is a fairly low energy form of energy. And so what we'll see is how infrared is certainly associated with heat and with heating. So let's go back to our ultraviolet spectrum. So what we have is, this is obviously not to scale, but we have our sun, and it's emitting UVA, UVB, as well as UVC. We have, in terms of our atmosphere, we have our stratosphere, which goes to even up to 50 kilometers, very, very, very thin, but we still certainly do have an atmosphere there. Around about 30 kilometers, we have our ozone layer, which is made up of stratospheric ozone. And this ozone layer around 30 kilometers protects us from the UVC radiation from the sun. Then what we have is we have our troposphere. We have got surface ozone, which is associated with smoke and smog from industrial areas. Ozone is really not good for us. It's has a huge oxidating potential, and so what it does is it burns our cells. So ozone is, even though it protects us, because it is in the ozone layer, it's actually not very good to come into contact with. So the thing is that we do have some ozone in industrial areas, which is really not good for us. But the thing is that the ozone layer does not protect us from UVA and UVB. So on the right-hand side here, we can see that UVA is always responsible for aging and for wrinkling, because what happens is that it gets absorbed by the dermis of the skin layer, which is the lower skin layers of our skin. And so that is why it's responsible for aging and wrinkling. But then the UVB, this is when we experience a sunburn, what is happening is that it's the epidermis, which is that upper skin layer, the skin of our skin, the upper skin layer, which is being burnt by UVB. And this is related to skin cancers. So that is why people always say, please, you have to wear sunblock. You have to guard yourself against sunburn, because that is what's going to give you the skin cancer. Now for the infrared. So what we have is, once again, not to scale, we have our sun that is radiating light towards us, natural light towards us. And with our UVA and our UVB, as we saw before, what we also have, and our UVC, which is stopped by our ozone layer, we also have infrared. And infrared, being the relatively low energy wave, is able to pass through our atmosphere. And as those rays of sun pass through our atmosphere, what happens is that the atmosphere, the molecules in the atmosphere, the oxygen and the nitrogen and the argon, carbon dioxide, etc., what they do is that they absorb a lot of the heat or a lot of the energy from that infrared light. And so there's a lot of absorption of that heat as the light comes through our atmosphere. And then if that light is reflected, because maybe there's a desert, there's a very reflective surface, maybe it's the surface of the ocean, and as it's actually reflecting the light back out through the atmosphere, even more heat gets absorbed from that light. So the thing is that what we can see here is where we've got green areas, maybe we've got forested areas which are not very reflective at all. What happens is that we don't have that double heating of the atmosphere because we don't have that reflection. Another thing is that forests and areas with a lot of vegetation absorb a lot of carbon dioxide. They absorb a lot of those greenhouse gases because they then convert those to food, because that's what plants thrive on. They thrive on converting carbon dioxide to carbon in their cells, and then what they do is that they expel the oxygen, which we in turn prefer as being of the fauna. What we do is fauna will absorb the oxygen and expel the carbon dioxide. So the thing is that with a buildup of greenhouse gases are incredibly effective at absorbing energy as heat. So the more carbon dioxide, the more methane, the more greenhouse gases we have in our atmosphere, the more energy gets absorbed from the sun rays. And that is why we have global warming. That is why we have this greenhouse effect where our atmosphere just keeps on getting warmer and warmer and warmer.